Hello, my name is Kafidakis. This is my Lab 2 for microprocessors. Um, Up here are my arrays. I've set their memory location. Here's the main loop that we were provided with. This is the setup for my first array, and then following is the setup for my second array. Each bit is assigned a value. Then we have the copy, which is called in both sorts on line 39 and line 45. And it's pretty simple. The first bit in both arrays tells you how many items are in the array, kind of the n number. We increment that to account for it in the array. Then we move R4, register 4 to register 5, and register 6 to register 7. So we're basically making a copy of where are they? These two registers right here. Because 4 is pointing to array 1, 4, and 6 is pointing to the sorted array of array 1. And the same thing will happen in sort 2. We're basically making a copy so that we can manipulate them a bit. And then right here is where the loop starts. The content at register 5 is going to be put into the first bit of register 7. So we're basically transferring every bit from register 5, which was previously register 4, into the sorted array, which is now held at register 7. And each time we do line 80, this will increment by 1. The memory address will increment by 1. And then we are also incrementing the word of register 7. And then we are decrementing R10, which is our counter of numbers. And then we do a check if the 0, if it's not 0, this is the 0 flag. And it'll jump back to here if it is not 0. And if register 10 is 0, then we know we return to the where it was previously called. Yeah. So we do that, and then we move on to the sort, which is the meat of the program. So I've cleared register 13. We're going to move the first bit of register 4 to register 10, and that again is just the number, the n number. Then we're going to decrement R10 to remind us to get rid of that n number. Then this is where the out loop kind of starts. So we move register 6 to register 4, and remember register 6 was previously the sorted array. So now we're moving all that into register 4, and the content of register 4 is going to put into register 7. Then the memory address is going to be incremented at register 4, and this is going to happen at the bit phase. Then we're going to do the subtraction here at the bits. Then we're going to decrement R7. And then this statement is the compare. We're comparing the bits. So we're comparing the this register 4 bit to the first bit. And if it is greater than or equal to, we skip, meaning that the first one is already greater than this one is already greater than this one, so we would skip it, and we would go down to here. We would decrement register 7, which it's given its values up here. Then if register 7 is not 0, then we're going to jump back to this in, and we're going to do this all again and again until register 7 equals 0. Then that means we continue. We're going to increment register 13, we're going to decrement register 10, and then we're going to jump back to the out. And then we're going to go through this loop a lot of times for both arrays, and you'll be able to see it. So we'll go ahead and run the program. So here's our memory browser, and then over here are the registers, and we'll make it a bit bigger so we can see all the registers that we're using. There. Alright, so we'll step into this. We're clearing register 4, 5, and 6, and then we're having R4 point to array 1, and then the other one, all this stuff. And then this is where it really starts. This is where the copy begins. So we call the copy. We're going to step into that. And that holds kind of the count, the number of the array. Then we're going to increment it to account for that spot. Then we're moving R4 to R5. R4 is now into R5, and we're going to move this into R7. And then we're going to proceed with this line. So R5 should go up by 1, so it should be 0, 2, 0, 1. And we'll see that happen over there. And this data, I don't believe, is really going to change much right now because I've gone through this a lot of times. And then we're incrementing R7. And then we're following the loop. So, we'll do this a couple times, but we'll continue. And then, so these are all those values that we just got. And now we're going to go through the sort array. So we're saving it there, and then we're decrementing it. And then we're moving R6 to R4 because this is where the start of the copied values that we had. So that's what we did there. Now we're moving the bit of R4 to R7. So we're looking here, and we're looking here. So we moved that bit, and then it got incremented 1. And that was that first one. That was the number, the n number. And then this line, nothing really happens right now, but it's an important line. And then we're decrementing R7. So it was a A, now it's a 9. And then I believe we do skip. No, we don't. Okay. I'm going to go ahead and go through all this. And then the same thing happens for sort 2. So this word, these 5 words, is the sorted values of array 1 from here to all the way to 218, 0, 218. And then these, I believe, are the sorted values of array 2. So there's 2 extra bits there. And that is the end of this.